Hello friends, I'm Snigdha Kakkad and this is my YouTube channel Accelerate.ai Careers. So this is the first chapter of my generative AI playlist which is targeted to help you start at a beginner's level, become acquainted with the theoretical as well as practical concepts in the field of generative AI. We'll also do hands-on projects in parallel that will help you learn more in depth and become an expert. This particular chapter for the playlist is majorly aimed at understanding the foundation models, large language models, and a brief introduction to generative AI. If you really like my lessons, please like this video and subscribe to my channel. If you feel that I should prioritize some other topics which you feel essential are in this field, please mention it in the comments. So let us begin our journey. So, friends, you must have worked with ChatGPT, OpenAI's Dali, or Google Bard in last 6 months to do some or the other task for you. And it's quite evident that this technology is not just a flavor or a change for some time, but it is here to stay. And it's going to change a lot of processes. So, a reasonable question that one may ask is, what is generative AI? So, let's start from the very basic here. Any kind of application that you create in this field, it rests in the universe of artificial intelligence. AI is the main universe. It is basically an artificial intelligence based application. Now, when we talk about machine learning is a subset of that AI universe. It basically offers you a set of tools and techniques to solve complex problems, such as regression, classification, clustering, forecasting. It is based on datasets on which a custom model is trained or fine tuned. When we talk about deep learning is a subset of machine learning. It basically came as a concept when scientists started wondering if they can make machines learn like humans, behave like humans. That is where the concept of neural network came into picture, which powered the way to deep learning solutions and applications. There are so many use cases for deep learning we are using in our day-to-day lives, such as recommendation engines, object detection, chatbots, sentiment analysis engine, word-to-word translation, news classification, image segmentation, object detection, image enhancement, and so on. Deep learning performs better when we have an increased amount of data. It basically rests its basis in multi-layered neural networks, such as artificial neural network, recurrent neural network, convolutional neural network, transfer learning models such as VGT19, and so on. If we talk about various versions and series of RNN, then it's bidirectional RNN, LSTM, transformers, encoders, decoders, autoencoders, BERT models. There's a very famous paper, Attention is All You Need, that forms the basis for self-attention mechanism and transformers. These models power various NLP applications, such as text summarization, text classification, sentiment analysis, and so on. Now, when we talk about generative AI, as the term itself indicates, that these are all those models which generate new data by learning in a human like fashion. It is not just extracting data from various citations or sections of text or documents, it actually gathers the information and it is trained on such a vast amount of data that it generates data in human like manner. It actually, as the diagram indicates, is a subset of deep learning. It includes those models which can not only extract information but also generate new information as humans do. Now, LLMs, that is large language models, are generative models that work on text data. Generative AI is the bigger umbrella which includes generating audio, video, music, image, text, or code data. Large language models is a subset of generative AI models that works on text data and generates text information. I hope that clarifies the different terminologies in AI and what generative AI is and what it is not. Now, you must be wondering, I've heard so much about generative AI now, but what's the difference between generative AI and discriminative AI? So, discriminative AI, the models are trained for specific use cases and they're not easily transferable. They need custom fine tuning to make them use case specific. On the other hand, generative AI based foundation models are already trained on such a vast amount of data and provided reinforcement learning as well that they can perform really well on unseen use cases with zero shot or a few shot prompting. Thus, there is no fine tuning needed for specific use cases. Instead, some prompt engineering or prompt tuning helps. We will discuss this very soon, what prompt tuning is, what prompt engineering is, what do we mean by zero shot prompting or few shot prompting. But for now, we can understand that foundation models or generative AI models are already trained on such massive universe of data that they can do unseen tasks or unseen use cases with great efficiency and effectiveness without much of customization. Now, why is it suddenly gaining traction? What's the change? Why wasn't it known before? The primary reason behind this is that a plethora of generative AI models such as ChatGPT by OpenAI, Llama 2 by Meta, Bard by Google, Granite by IBM being made open source, and their APIs are readily available for custom applications. For instance, if we just pick a subset for generative AI, that is large language models, then there are so many applications being powered by large language models, a quite common one being a chatbot assistant. You can customize it quite easily for your industry specific use cases and documents such as healthcare assistant, education assistant, mortgage assistant, policy document assistant, banking assistant, and so on. Now, when we talk about how foundation models differ from the discriminative models, the approach of fine tuning discriminative models was resource intensive, time consuming, and it relied heavily on largely labeled datasets. For foundation models, that's not the case. Before discovering foundation models, let's look at various types of generative foundation models. The overall deep learning can be classified into discriminative AI and generative AI. Now, discriminative AI models could be multi-layered perceptron models, RNNs, recurrent neural networks, basically convolutional neural networks models, whereas the generative AI models could be generative adversarial networks, variational autoencoders, or transformer-powered models. We'll look into each of them with architecture in the second or third chapter. But for now, you need to understand which models are categorized as generative AI models, whereas which models are characterized as discriminative models. Now, we have already covered here that what was the disadvantage when using discriminative models. They were basically very resource intensive, time consuming, and they relied heavily on labeled dataset for fine tuning to custom use cases. Whereas foundation models are generic, they are trained on such large amount of data that they can easily be customized without much need of labeled data to specific use cases. Now let's talk about foundation models in detail. Foundation models are basically powered by artificial intelligence. They are trained on massive amount of internal data, including text, image, video, audio, code, and they are mostly trained on unlabeled data via supervised learning. These models have also undergone positive and negative curation cycles by humans during training phase to avoid any hallucinations and biases. These are large AI models basically that are generating real time text, creating beautiful images, live music. Instead of one model being trained for one task, these foundation models formulate a basic basis for so many custom applications. They are trained on such large amount of data that the pre-trained foundation model can be used for multiple tasks without much need of use case specific data such as generating stories, summarizing documents, answering question based documents, writing code, translating code, debugging code, solving statistical or mathematical problems, translating languages, or assessing the sentiments of streaming text and reviews. The use cases are endless. And several companies are exploring these foundation models and their use cases. They're driving value for their customers by customizing these models. Now, at the very core, these foundation models are large neural networks. They are pre-trained on large corpora of data as indicated earlier and absorb vast amount of information. Now, what are the various layers which formulate a foundation model? The very first layer is the base, which involves generic pre-training over exhaustive data in which the model learns from a corpora of huge internet data via supervised learning. The diverse context could be text, image, code, video, audio, etc. Now, the second layer is the middle layer, which is domain specific refinement, which narrows down the model's focus. The third and the final layer is precision. It basically fine tunes for specific use cases and custom applications, could be text summarization, could be sentiment analysis, could be image generation, and so on. Now let's take a closer look at foundation models. So as you can see from this diagram, the data on which the large amount of data on which the model is trained is gathered from internet. It could be text data, image data, speech data, structured data, 3D signals. That data is vet first. It undergoes a cycle of positive and negative creation. And after curation, that data is used for training the foundation model. Once the foundation model has undergone a training process, then it can be customized and adapted to specific tasks. The task could entail question and answering, it could entail sentiment analysis, information extraction, image capturing, object recognition, or a combination of these, such as named entity recognition and then text classification, or named entity recognition and then question and answering. So, a single foundation model can be customized for so many use cases. Now, the large scale data training process and generalization across the task is something which happens after the foundation model is being trained upon. Now, let's look at various types of foundation models. So, the first kind of foundation models, which I have briefly mentioned before, are large language models. These are the machine learning models which are trained on massive amount of text data, able to process and generate text using deep learning techniques. These have found a large number of applications. ChatGPT, Llama 2, Bard, now Gemini, all these are kind of examples of large language models, which are trained on heavily on text data and generate new text information. They can be customized for specific use cases such as named entity recognition, sentiment analysis, text classification, text summarization, translation to different languages, and so on. The second kind of models, which are also categorized as foundation models, are diffusion models. These are generative models. They generate data similar to the data on which they have been trained upon. They could be either used for image synthesis or speech synthesis. They can also be used for video synthesis. These models work by introducing Gaussian noise into the training data and learning to process that noise that was originally injected and recognize the original data out of it. So basically, it can regenerate new image from original data. For example, Delhi by OpenAI, Imagine by Google, and Glide are examples of diffusion models. There's a very famous application these days called Midjourney. It uses one of the diffusion models to generate different kinds of new images. So basically, in the future, we can see a lot of use cases and applications for both large language models and diffusion models going on in the industry. And those applications could be adopted at a very large scale. Now, in our upcoming chapters of this playlist, we'll learn more about these LLMs and diffusion models, the architecture, which is underlying these LLMs and diffusion models, and the use cases, and we'll also take up some projects to implement these from end to end and deploy them. So let's delve deeper into series of foundation models available in industry landscape and some of the popular LLMs in the upcoming playlist. So if you like my sessions, please like this video, subscribe to my channel for the upcoming videos in the series of foundation models and generative AI. If you feel that I should prioritize some other content or some essential topics in this field, please mention it in the comments. I will prioritize it. So let us begin our learning journey together for this field. Thank you.